Do you feel a little overwhelmed when scrolling through your Ancestry DNA matches? A great way to tackle thousands of matches is to download them into a spreadsheet that looks like this. This is my DNA spreadsheet. I've got the match name, number of centimorgans, the type of tree, that could be public link tree, unlinked tree, private link tree, or no tree. The tree size, this for me is the most useful column of all. I can choose to filter or sort in descending order so I can focus my research on the medium to large size trees. The match side, where it's assigned, the relationship, and finally the manage by column. It can be useful to sort or filter on this to show groups of matches managed by the same manager. Unfortunately, Ancestry doesn't give us a button that exports our match list to a file. You have to do it yourself. You can copy a page of your match lists into a spreadsheet, but what you get is this, a splurge of unorganized data. So how do you organize that into this? I used to use an Excel macro, which is a piece of code that runs within Excel. Google Sheets lets you run JavaScript. The problem is that Ancestry occasionally changes their web page. For example, adding the paternal and maternal side. That information used to be shown on this display. My macro would break, and fixing it each time Ancestry changed the display was a real pain in the neck. I've been looking for ways to have these new AI tools help me with my genealogy research, and I figured this is a job for AI. I'm going to show you how to download your DNA match list from Ancestry. Then I'll walk you through using AI to create a program that organizes the splurge of data into a proper list you can work with in a spreadsheet. I'll show you and explain the prompts I used to create the program. That way, if Ancestry tweaks the display, you'll know enough to be able to tweak the prompt to produce a new program. You're going to need access to a free GPT tool. Any of these are fine. Program will be Python script, and you'll need a way to run that script. I'll show you how to use a free Google platform that lets you run Python. You don't need to know or understand Python to follow along. This video shows every prompt I use in full, so you can type them into a GPT chat window. But maybe you're in a hurry and you just want the final solution. I've collected all the prompts into a PDF, and I've prepared the final Python script that works with the current Ancestry display. This is available together on the Data Mining DNA online store. The link is in the description below. I'm logged into Ancestry. I'm on the home page. I'm going to go to my DNA match list. Before I copy the contents of the page, I click on Filter. Then I expand the Shared DNA section. I filter on centimorgans because the low centimorgan matches are usually more challenging to research. I may choose a cutoff point of 10 or 15 centimorgans. You may prefer to go lower. I'm going to filter my matches so that they have a minimum of, I'll take 15 centimorgans. I'll take the max of 3490. That's basically all your matches now from 15 and above. I'll hit apply filters, and that will have reduced my list down. I scroll down to the end of the page. I'm now going to change the items per page. I'm going to change it to 50. And if you look up at this URL here, you'll see the filters in the URL that have been applied. So it's saying, show me my matches where the shared DNA goes from 15 to 3490. And if I scroll over to the right, items per page equal to 50. Now here's the trick. It'll have the amount of time that we're going to be copying matches. I'm going to change that 50 to 100. Make sure the equal sign remains, otherwise this won't work, but I'm going to change it to 100. You may be wondering, oh, why don't I change it to 200 or 500 or 1,000? Well, they won't work. This will work if you change it to 100. It will display 100 on the page, but if you change it to anything above that, it won't. I've changed it to 100, and now I hit enter on my keyboard, and now I have to wait a little bit. This is now displaying 100. Before you copy this data, make sure you scroll down to the end of the page. But sometimes the Ancestry page can take a little bit of time to display right down to the end. And when you copy, you'll just get empty spaces here, right? So you want to make sure that the page is actually displayed the full set. So the next thing to do is to copy the contents of this page. To do that, I am going to hit Control A. For Control A, it has selected the entire contents of the page. So this has now just selected the data. It hasn't copied it. So after Control A, hit Control C. Now it's in your clipboard. Now I'm going to paste the contents of my clipboard into Notepad. Because I'm on a Windows machine, if you're on a Mac, you might use Text Edit. I'm going to launch Notepad app. To paste, I hit Control V. This is the contents of the browser page 1 of 10. Beneath this, I want page 2. So I'm just going to hit Enter to give myself a new line. And this is where I'm going to paste the next page. So I swivel back to Ancestry. Next, scroll down to the bottom. Just wait for everything to appear in terms of the display. Control A to select all the contents. Control C to copy to my clipboard. Swivel over to Notepad. I'm down the bottom of Notepad. Cursor in. Control V. And now I have page 2 of 10. Give myself a new line. I'm going to go back to Ancestry and you guessed it, going to work through page 3, page 4 and so on. And you work your way through as many pages as you need. And I am going to now pause this video and I am going to copy the lot. So be back soon. Back again. I've reached the last page of my filtered matches. The right arrow is grayed out. I can't go any further. And page 10 of 10. So now we have our file with matches. Let's take a look at how it's organized. That's going to be crucial to what we do next. I'll scroll to the very top of the file, and at the start here I see the header information that is basically the menu along the top of the Ancestry page. I scroll down and then I come to my first match. I'll just swivel over to the Ancestry page just to give you the context here. We've got the match avatar, the symbol in green, which is not against most of my matches, just shows that I've linked this particular match into my tree. We then get the match name, we get the relationship, we get the side, paternal, maternal, sometimes unassigned, we get centimorgans, percentage shared DNA, information about the tree, a common ancestor, which isn't always present, and occasionally, if I scroll down, I have a match name, and then I have a manager name. And how this comes down as our copy is there is the match name. That's the information that match is connected to my tree. The match name appears twice. Same here, twice. Same here, twice. Relationship, maternal or paternal side. The number of centimorgans, and then we have this pipe symbol. That's going to be crucial for us. And then the percentage of DNA. Underneath this line with the pipe symbol, we will get the tree information. It can be no tree. There will always be something here about the tree. Depending on whether the tree is linked or not, below the line about the tree, we will see the number of people in the tree, the size of the tree. And if I scroll down to find an unlinked tree, you will see the information stops. There is no information about the size of the tree. Now, for my close family up here, I do get the line underneath the number of people that there's a common ancestor. I will only see a common ancestor appear if the tree is linked, and quite often it doesn't appear anyway. So for example, with this person, it is a linked tree, I get the size of the tree, number of people in it, but I don't get any details about a common ancestor. This add, toggle over, it's this button over here, add. And then finally, you might be wondering what this light red, blue, dark yellow, etc. is. Those are the groups. Toggle back over, and this particular match, I have 5 groups. The crucial part, though, that I want to point out is that the order of how the information appears is consistent, but some pieces of information aren't always present. And because it's consistent, we can extract the information into a tabular format, like as in a spreadsheet, by using code. You're going to use an AI tool to create that code, but we do need somewhere to run it. I'm going to use a free Google platform called Google Colab. You just need a Google account to use it. So let's get you started on Google Colab. Google Colab. So it's colab.google. If you're logged into a Google account, you don't have to sign in again or sign up. What you can do is go straight to New Notebook, either here or up here. I'm going to click it here. I'm logged into a Google account. If I wasn't logged into a Google account and I click New Notebook, it would give me the login screen. Log in, and then you will be taken to this new notebook. Notebook is where you put your code. This box here is called a cell. We can put our code into the box and we can click the run command. What I'm going to do is the classic first piece of code that you ever write. I'm going to print hello world. So type print with these parentheses, quotation, hello world, and then I click the run button, and it's initializing down here. It connected to the Python engine running on the Google servers, and it has printed hello world. Next thing we're going to do is we're going to upload our file of DNA matches so that we can use code to analyze the file. Now, the thing to remember is that when you open up a notebook in Google Platform and then you stop using it and disconnect, your files go away. The files that you've uploaded don't persist there. That would be a security issue, really. They just disappear. So make sure you keep your files on your laptop or somewhere you can get at them. So how do we upload a file? This folder here, files, expand that, and Google give us some sample files. I'm just going to expand that folder, sample data, and it gives us these sample CSV files. I am going to upload my DNA match file into this sample data folder. So I'm hovering on the line sample data, and I get this ellipsis, these 3 dots. Click 3 dots and click upload, and then go find your file on your local machine. I'll just take this full file of 2000 matches. I'll click open, and here's where it's telling us that it will eventually be deleted when you stop using the platform, when you close the browser. So click OK, and this is where it has loaded the file. And we're not seeing the full name. I'll just expand it there, and that's what I named my file. So now we're going to use an AI tool to give us the code to grab the data that we want about the matches, put it into a tabular format, and we will actually save the file in tabular format back into this area where we can download it and we can open it up in a spreadsheet. Now, you may notice Gemini kind of appearing in lots of different places. You can, if you like, use the Gemini AI tool here. And let me see if I can get this display right. Got more tab options. Two columns. And I'll scroll over here. What you can do is you can type your prompt over in this window here, and it will give you code that you can pop here. I just find this window so narrow. I just find it very difficult to work with this kind of split screen. Gemini is fine though. Gemini will work perfectly. I mean, what it would look like if you're typing over here would be something like, give me the code to display hello world. It's thinking, and it's giving me this print statement. I can then copy this, and then you might be wondering, well, what do I do here? You can either overwrite the contents in that cell, or you can simply add a new cell by clicking plus code. That gives you a new empty cell. And this all gets a little bit busy, but I can now Control V because I used that copy to copy this. I can Control V and I can run this. And hey, it works. So everything I show you now in terms of the prompts, you can stick them in here and get the code. I just find this display not very useful. So I am going to use a different AI tool, by the way. Instead of using Google's Gemini, I think more people are used to using ChatGPT. Google's Gemini is free and it also works fine for this. Perplexity AI, Claude, I've tried them all and they all work fine. If you decide to use an AI tool in a separate browser page and copy the code back over here, you may find that Gemini just gets in the way. What I do is I turn it off. I'll just show you my settings. If I go to Open Settings, I go to AI Assistance and I click Hide Generative AI Features, makes it go away, and then I will close that tab. So now I have a nice big window for my code and what I'm going to display, and I have the file over here. Before I jump over to ChatGPT, I am just going to name this notebook. It's been given the name of Untitled 0 with that extension that stands for Interactive Python Notebook. I'm going to name this Matches. So I'll just get rid of these sample cells. I'm hitting the trash button. There we go. And I'll give myself a new code cell. And now I'm going to go to ChatGPT. I'm using the free version. ChatGPT.com. I already have a number of scripts where I was testing this. And ChatGPT can now remember what you've done before. So I want to be sure that what I'm giving you work if you've never engaged with ChatGPT for this purpose. So I'm going to give myself temporary chat. What that means is that it won't use memory. I'm going to ask it to help me interact with the file that I've uploaded to Google Colab. I'm going to ask it to count the number of lines in the file. I'm going to give it context. I have DNA matches on Ancestry.com. I have copied the browser contents that list my DNA matches to a test file. I'm going to hold down Shift and hit Enter just to give me a new line. Now I'm going to continue. I uploaded the text file to Google Colab. The location is, and now I want to give it the location of that file. In order to get that, I'm going to go back over to where I uploaded it. By the way, it signed me out because it does periodically kick you out, right? And if it kicks you out, then your file goes away, right? Remember, it doesn't hold on to your data for security reasons. So because I had been doing other things, it kicked me out of my session and my file is no longer there. Not a problem. I'll just upload it again. Ellipsis, upload. This is my file. Give it a little bit of a chance to get in there. It's working away. There is the file. Now, I want to give the code is going to read that file, but it needs to know where it is. And the simplest way to get that location is hover over the file. So you're highlighting it. Click on the ellipsis and click on copy path. So I'll copy the path into my clipboard. I'm going to go back to ChatGPT and I'm going to tell us where it is. So the location is just open quotation marks there, Control V, and I'll close the quotation marks. And now I want to tell ChatGPT what to do. I'm going to tell it to create a Python script that does the following. Step 1, open the text file. And step 2, I'm going to start simple. I'm going to get it to count the number of lines in the file. Count the number of lines in the file. And then step 3, display the count. Submit that. It's thinking about it, and then it's giving me code. It's also offering a suggestion. The file isn't super large. If you're using Gemini, it might decide to put some of this code into a slightly different structure. It might give you a function at the top and then it'll call the function. It's just a little bit more complex. Don't worry about it. Just hit copy on the code. It doesn't have to look exactly like this. Toggle over to Google Colab and just paste that script into the cell and click run. And it's telling me the total number of lines in the file. Haven't checked. I'm going to believe that that is the total number of lines in the file. So the next thing I want to do is I want it to count the total number of matches, of DNA matches in the file. I wanted to read through the file and count the matches, but it has to identify where one match ends and the next match starts. Let's display our file again. Here's a file. Let's scroll down. And there was one piece of text that consistently appears around about the middle of every match. It is this text here with the pipe. Remember I said that pipe is going to come in handy? I would need a piece of text that appears within every match but doesn't appear elsewhere. And that pipe symbol doesn't appear elsewhere. And where this becomes important is if you put in a lot of notes into Ancestry for your matches. Here's a note that I added for G123. We need to be sure that when we're telling ChatGPT that there is text that appears only once for each match, that it's not a piece of text you may use in a note. But you're highly unlikely, I think, to use the string CM space pipe. So that is going to be my anchor line to say that this is somewhere in the middle of a match. There's interesting information above it and interesting information below it. So if I want to know the number of matches in this file, I need to count the number of occurrences of this piece of text. I'm going to ask ChatGPT to give me the code to do that. So I'll just copy this. So it's C capital M space pipe. And if you can't find the pipe in your keyboard, for me it's down near the shift key, but just copy it from your notepad file. And now I'm going to go back to ChatGPT and I'm going to ask it to amend this script. And I'm going to ask for a new script. So I'll copy my preamble, but now I'm going to give it some new information. I'm going to tell it in the file structure, every DNA match has one line containing little c, big M, space, pipe. And now, having given that crucial piece of information, I'm going to tell ChatGPT to create a Python script that does the following. And I am going to spell it out a bit just so that there's no ambiguity. Open the text file to find all lines containing CM space pipe. 3. Display the number of lines with that text. I will submit this. And it's inferred from what I've given it in terms of my instructions, is that I want to count how many matches. I said find all lines containing CM space pipe, but I told it that every DNA match has that line. So when I say display the number of lines with that text, it knows that what I really want is play a count of how many matches have the text. So this is a loop for every line in the file. If that line has this text, increment the count. I'll hit copy, go to matches. I'm going to add a new code cell, plus up here, paste, and let's see how it gets on. 2000 matches. So now we know that ChatGPT can give us a script that finds this piece of text. And if we find that piece of text, then we can also get it to figure out you've got the number of centimorgans and you've got the percentage of shared DNA. Below the line, you've got tree information. Above the line, you've got the match name and other info. So we can use this text to find the line that becomes the anchor line, where we can get info from it, plus info from lines below and above it, by being pretty careful and explicit in what we tell ChatGPT. Now I want to start getting the information about those matches into a table format that I can open in a spreadsheet. And I need to tell ChatGPT that that's what I want to do. Go back to ChatGPT and I am going to take down this preamble. Now I'm going to add some more information as to what I want. I want to extract information about every match and put it into a table. I want to start with the match name. If I toggle over to my match file, you can see that the CM space pipe here, usually the match name appears 1, 2, 3 rows above the CM space pipe or anchor line, but not always. If I scroll up, here we go. Connie has a manager. There is CM space pipe. And when I count up 1, 2, 3, 4, because the manager, if it's there, is below the match name, that pushes the row that I'm interested in up. So it's 4 above. That's probably one of the more complex pieces of logic we need for this script, but we may as well start there. I'm now going to give that information to ChatGPT. I am going to tell it to create a Python script that does the following. Open text file, find all lines containing M space pipe. Use the position of other lines relative to the line with M space pipe to retrieve the match name and manager name. So instruction 3 is too vague. I need to tell it exactly what to do. I am going to give myself a colon. I can't tab in. I'm going to just give myself 5 spaces. 1, 2, 3, 4, 5. A. If the text 3 lines above the CM space pipe line starts with managed by, then the manager name follows the text managed by with a space. So we're here, we go up 1, 2, 3, and if this starts with managed by, then the manager name is after managed by in space. And then the match name is one line above the manager name. Now, what happens if the text 3 lines above the CM line does not start with managed by? I'll copy this down and I'll just edit this. If the text 3 lines above the CM line does not start with managed by, then there is no manager name. The match name is 3 lines above the CM space pipe line. So that is the logic. So the final thing I wanted to do is, display the first 10 matches in the table. Submit that. So this is more complicated, right? And it's thanking me for explaining it clearly. Let's see what it's doing. This line at the top, by the way, I told it to create a table. It's using a very common way in Python to do that by using this pandas library. It is creating this empty table. It's looping through every line. If it can find the anchor text in the line, I mean, all the work is actually here. Each time that it finds the match, it's adding that particular row into the table with the match name and the manager name populated with 2 nice column names. And then here it's going to show me the first 10 matches. Let me copy this, toggle back, give myself a new cell, Control V, run. I can see that the first 5 matches don't have a manager, but we get to Una Mac, her manager is Marie. So we have a table that has 2 columns, and there are 2,000 records in that table. I'm just showing the first 10. Back to GPT. So the next 2 pieces of information that I'm going to grab, toggle back from the line with CM space pipe. I want to grab the number of centimorgans and I want to grab the percentage of shared DNA. Back to ChatGPT, and I'm not now going to keep repeating the full instructions because within the session, even though I'm using a temporary chat, within this particular session, it will remember what it's done. So instead of repeating all this, I am going to ask it to extend the script. I am going to tell it, please extend the Python script as follows. After retrieving the match name and manager name, get the number of centimorgans and the percentage of shared DNA. Now, I have to tell it where that is. For each line with capital M space pipe, it put down as follows. For each line with CM space pipe, the number of centimorgans is the text to the left of CM space pipe. And then I just copy this. So again, for each line with CM space pipe, the percentage of shared DNA is the text to the right of CM space pipe, but I don't want some of that text. So I will tell it remove the text shared DNA. If I don't give it the column names, it'll give me quite lengthy column names. So I'm going to say use column names CM and shared. Give it that. So here is where it's doing the new logic. I'll take that. Sometimes if you come back here and you've been away for a while from Google Colab, your session may have stopped and you restart it, you put in your code and you get an error saying it can't find the file. It's because the file has disappeared. The session stopped, so the file disappeared. You just have to go and upload it again. Anyway, I'm going to give myself a new code cell and I am going to paste this in and run it. Looking good. There's my CM, there's my shared. What do I want next? I want the relationship. So I want second cousin, third cousin. Ancestry can make these relationships quite long, but they're always there. So relationship, a little bit easier than match name and manager name because the relationship is always 2 lines above CM space pipe. Back to ChatGPT and I will extend the script. So please extend the Python script as follows. Retrieve the relationship with this logic. I won't say as follows again, but odd. So with this logic, 2, 3, 4, 5 spaces. The relationship is 2 lines above the line with CM space pipe. And you know what? I'm going to double things up. Relationship is always 2 lines above because the parental side on the sign paternal is always 1 line above. So I may as well give it the instructions to get both. Retrieve the relationship with this logic, and then I'll say retrieve the parental side with this logic. 1, 2, 3, 4, 5 spaces. The parental side is 1 line above the line with CM space pipe. And then I'm going to tell it what column names to use. Use column names, relationship, and side. Give it that. This is the new logic. And then I don't want it in that order. Okay, I'm going to tell it to have it in this order. Please amend so that the order of columns is match name, manager name, CM, shared relationship, side. It's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right. So it really should give me the same script. And this time it's ordered things quite specific here. I'll copy this over to Google Colab, hit paste, and run. So you might be thinking, well, it's all gone wrong. Actually, it's just a display thing. See this slash here? It's basically telling me that it doesn't have enough space to display stuff, so it's wrapping it around. These 9, or I should say these 10, because it starts at 0, these 10 rows match those. But that's really horrible to see. It doesn't really matter because I'm eventually going to be saving this data to file and putting it into a spreadsheet, but it actually helps to see any mistakes you've made if the display is is meaningful. So I am going to tell ChatGPT to give me some code that will ensure that this display uses a wider format. Back into ChatGPT. Please amend the script to ensure that the display of the table is 180 wide. But it'll know what I mean. Yeah, 180 characters. So I'm just going to copy this back to matches, new cell, paste, and see what I get. Okay, yeah, that's better. I'll even bring this over to the left to give myself more space. But my 10 matches, there's a relationship. Now, the relationship is being truncated, that's fine. It's not going to be truncated when you save this to file. Back to the file. And the tree information is always in the same place. It's always 1 line below our anchor line CM space pipe, but the rest of the information about the tree may or may not be present. So where we have a linked tree, whether it's public or in this case private, the size of the tree, the number of people, is 1 row below. If it's an unlinked tree, then no size is given. And there can also be no tree. No tree is obviously no size. And then the common ancestor is also based on there being a linked tree. If you have an unlinked tree, there won't be a common ancestor. But even if there is a linked tree, the common ancestor may or may not appear. So let's focus on the type of tree. So back to ChatGPT. So I am going to ask ChatGPT to extend. Please extend the Python script as follows. First thing I want is to get the tree type. The tree type is 1 line below the CM space pipe line. Now, size may or may not be present. You can figure out whether it's present or not in several different ways. I'm going to use the fact that the word people appears when there's a tree size, except in one specific case. There's only one individual in the tree, then it's one person. The tree type is 1 line below the CM space pipeline. And now the tree size may or may not be there. If the line 2 lines below the CM space line is a little bit less ambiguous, if the line that is 2 lines below the CM line contains the text people or person, then extract the text that appears before those words. This is the tree size. So if the line that is 3 lines below the CM space pipe line, below the line, is exactly the text common ancestor, extract the word common. This is the common ancestor. This is the presence of a common ancestor. Now, I really do want to give ChatGPT the name of the columns because I don't want a column called presence of common ancestor. It's too long. So use these column names: tree type, tree size, and common. And now the order that I want things in, please order the table as follows. So this is the current order. So the tree type and the tree size for me is more important than the side, or indeed that common ancestor. So I want it about here. So I'll have tree type, tree size, and then that parental side is kind of useless for me, so I'll keep it last, but I'll put common here. Submit that, hit copy over to Google Colab, add code cell, paste, run. Now I've got a scroll bar here. Okay, no, that is the full data set. So the last thing I want to do for this video is to get this data, all 2000 matches, into a file on my local machine that I can open in a spreadsheet. I'm going to tell ChatGPT to extend the script to do that. It will be the last thing in the script. Please extend the script to save the table to a file. Now, I need to choose the type of file, so I'm going to choose to save it to a tab delimited file, which can be opened perfectly easily in Google Sheets or Excel or the spreadsheet application of your choice. Please extend the script to save the table to a tab delimited file here, and then I'm going to tell it where to save it to. What you can't do from Google Colab is save it straight to your local machine, because again, for security reasons, it doesn't have access to it. What I want to do is I'm going to save it in the same area that I uploaded my file. And in order to get the full path, I do have to give the full path. I'm going to just grab the full path of the file that's already there, hit copy path, and I'm going to amend this, and I'm going to Control V paste here. So that is the uploaded file. I now want to change this to, I'll call it matches. So it's in this folder, subfolder, and it's going to be called matches.txt. Submit that. Yeah, so it's actually telling me that what it's done is it's added the save to the end, and this is where it's saving it out. That will save the full contents of the table. I'll hit copy back to Google Colab, plus code, paste, and just keep an eye there on the left-hand side of the screen. I'll just expand it where I have these files. I click run, and that was pretty fast. There is my matches.txt. So now that file has been created, it will go away. Like when you close the browser, when you log out, this file no longer exists. So we want to download it. Click download, and that has come to my downloads folder. So I will go to sheets.google.com and I will create a blank spreadsheet and then go File, Import, go to Upload. Then I can browse, go get it. In my downloads folder, it's matches.txt. I want to replace the spreadsheet. I click Import. That's what I want. Relationship. Just expand that out. Expand out the tree type. That make that bold. View, freeze, the top row. And now I can do things like filtering on the tree size. And just for the people who have Excel, I will open Excel, file, just open, go look for it, downloads. So with Excel, I need to change the file type. I will change it to, well, I'll just change it to all files so I can see them all. There's my matches. Click open. My data has headers. Yes, because the column names are the header. Click the tab. Data looks about right. Click next. And I'm just going to click finish. And doing a bit of formatting. So there you have it. So there are other fun things that you can do with help of your AI tool and using Google Colab. For example, the tree type. Have you wondered what percentage of your matches have the most useful type of tree, which is a public link tree? You can do some graphing and some charting of the tree types across all your matches. If you're thinking, well, a public link tree where there's two people in it is useless, then you can do some graphing on the size of your trees. You can do some charts or graphs on the relationships. And in terms of your centimorgans, how many of your centimorgans are between 10 and 12, between 12 and 15. You can put them into bands and just get a feel for the distribution of your matches. If that's something you're interested in, I can do a video on it. It would be fun. And we can get the code for some really nice graphs and charts within Google Colab. And you can save the charts as images, download them, add them to your spreadsheets. Drop a comment if that's something you're interested in, and I can show you some really nice visualizations of your own data. If that helps. If you stuck to the end, well done. Hit like, hit subscribe, and best of luck with your family research.